In this video, I'm going to show you how to write the Fibonacci function from lecture. So this function is interesting because it has two recursive calls, which makes it more complicated than our previous example. So as a guideline, we're going to use the following process. So first, we're going to handle the base case, and we're going to do this without allocating a stack frame if possible. So our base case for this function is the if n is less than or equal to 1. So again, as typically done, we're going to invert this condition. So rather than less than or equal, we're going to have a branch if greater than. The variable n is in the register A0. So branch if greater than A0, and we're comparing it to 1. And if that condition holds, we're going to do the recursive case. The base case just returns n, so we're going to do a move into register V0 where our return address or return value gets put from A0 and do a jump register return RA. So that handles our base case, so we can handle now the recursive case. So let's see what our next step is. So allocate a stack frame and save the return address. So allocate a stack frame. At this point, we don't know how big that stack frame is, but we can go ahead and save our return address. Put in some comments. Okay, we've done that. Now for each call, in this case we're going to have multiple calls, we're going to do the following. We're going to save any registers needed after the call and compute the arguments. So now we have to do some analysis. So here's our first call to Fibonacci, and we look and we see after that call we're going to need the value n again so we can compute n minus 2. So I'm going to go ahead and save n. So n is in register A0. We're going to save that to a different slot of our stack. So we've saved n. Now we're ready to set up the argument for the first call to fib. So n minus 1, I can do that with adding, I'm going to add A0 and minus 1, and that's going to give me n minus 1, and put that back into A0 because that's where my argument goes to the call to fib. Now we're ready to do the first recursive call. So we've done the call function. When we're done, we need to restore any register values needed after the call. So we said the way we do that is we're going to restore values by cutting and pasting. I'm going to copy my store word and turn it into a load word. So now we've got a restore of n. And we have to deal with the return value of fib. So that's going to be in V0. The problem is we're going to immediately do another call to fib. So that call to fib is going to overwrite V0. So we want to save that return value before we continue. So save V0. We're going to put in a different slot. And so that's going to be the return value from fib n minus 1. Okay, so we got all the way through. We used the V0, we restored the n. Now we're ready to do this again for the second call to Fibonacci. So fib n minus 2. In this case, what do we need to save? We've already saved V0, so there's nothing more that we need to save. So the next step is to set up the argument. So again, we have n in A0. So we can set up the arguments by now subtracting 2 from n. Remember, we saved n, we didn't save n minus 1. And now we can call fib. So we've called the function, now we need to restore any registers needed after the call. Well, we saved V0, so we want to restore that value. The trick is we can't restore it back to register V0 because if we do, we'd overwrite the return value from this call to fib. So I'm going to actually restore that to a temporary register, in this case T0. And there we've got it restored. And now that we've restored it, so we should consume our return value. So we have the return value from fib n minus 2, that's in V0. The return value of this one is now in, this one's in V0. this one is in T0. We want to add them together and return that value. So we want to put that into V0. So we're going to put that into V0. What are we putting? We're going to put the sum of T0 and V0. And so this is our return value. And okay, so we made it through step 4. Now we just need to deallocate the stack frame and return. So before we deallocate the stack frame, and at this point we know how big our stack frame has to be. We're saving 1, 2, 3 values on the stack. 3 times 4, because they're each 4 bytes big, is 12 bytes. So now, before we tear down the stack, we want to restore the return address. So again, we're going to cut and paste and restore RA back into the RA register. Now we can copy this line, and we're going to convert that subtract into an add. That's going to tear down the stack. So that's going to return the stack to what it was before our call, and we're basically done. All we need to do at this point is jump register RA. And so that is how to write the Fibonacci function.